I'm now moving on to the homework questions in the very first lesson of the circle geometry chapter. And for problem number 1, I need to find the missing values. So for problem number 1, I need to find the value of AB, and AB is this chord right there. So for this particular problem, we just need to understand our basic chord properties. So if you have a radius that's starting from the center and it's going to the edge of the circle, and if it intersects any chord, which is this red chord right here, what that means is these two lengths have to be equal. So if this length right here is 4, then this length here also has to be 4. So 4 plus 4 gives you a length of 8. So the length of chord AB is 8. Okay, so that's it for that particular problem. For letter B, I need to find the radius. Now, if I take a look at this length right here, that's 15, and this length right here is 5. So 15 plus 5 gives you a diameter of 20. If the diameter is 20, that means the radius has to be half of that, so the radius has to be 10. Okay, let's move on to the next one here, letter C. Okay, so for letter C, we're not looking for a numerical value. The question is just wondering what's the relationship between the diameter, which is AB, and the chord, which is CD. Okay, so since the diameter intersects this chord, and since this length here is equal to that length, that means this angle right here is 90 degrees. And if that's 90 degrees, that means that the diameter is perpendicular to the chord CD because of the 90-degree box. So the symbol that we use to express perpendicular is this symbol right here, and that just means that 90-degree forms when the diameter bisects the chord, which is CD. Okay, let's move on to letter D. And for letter D, if I take a look at this radius right here in blue, well, that radius and this radius right here are equal. So if they're equal, then that means they're equal because they're both the radius or the radii. All right, so since they have the same radius, we have an isosceles triangle. And for an isosceles triangle, the general rule is for any isosceles triangle, if the two sides are equal, that means the angles are also equal as well. Okay, so mathematically, we know that all triangles add up to 180 degrees. And if I lose 110 degrees, then that means I have 70 degrees left. And that 70 degrees has to be divided equally into those two corner angles. So each corner angle has to be 35 degrees each. So that's 35 and that's 35. So angle A has to be 35 degrees. Okay, let's move on to letter E. Some of these questions we can move pretty quick. Now for letter E, a very similar problem here. We have another radius here, and that radius is equal to this radius. So right away we have an isosceles triangle. So if this corner angle here is 30, then that means this angle here has to be 30 degrees. So 30 plus 30 gives you 60 degrees, and 180 degrees minus 60 degrees gives you a value of 120 degrees for this particular angle there. Okay, so angle O has to be 120 degrees because all angles in a triangle add up to 180 degrees. All right, for letter F, this is very similar to one of the problems we had before. I know that this length is going to be 16 and this length here is going to be 4. So that means that the diameter, if I look at 16 and 4, the diameter is 20 and the radius is half of that. So half of 20 is going to be 10. So the radius there will be 10. All right, let's go over a few more problems here. For the next question here, I need to determine the missing length. So for this problem, I need to find the missing length of OD. And OD, since it's not on there, OD is just this distance right here. So the distance from O to D, O is the center, so OD is actually the radius. What is the radius in this particular problem? Okay, so we're given the value of AC, which is 20. So AC here, this whole length right here is going to be 20. And then we have the length of BC, which is 5. So BC right here is going to be 5. Okay, so that's the diameter. So the diameter is going to be 25, right? So the diameter is 25 if you add up the 20 and the 5. And the radius is half of that. So 25 divided by 2 is going to be 12.5. So OD, which is the radius, is going to be 12.5. Okay, moving on to the next question. For the next question, there was a small typo in this problem. I know the question is stating to find the length of OA, but there's no O here. And after kind of going to my notes here, the question is just asking for what is this blue distance right here. So I need to find that blue distance. Now, finding that blue distance isn't too hard because we know the radius here, this green line, that's the radius. The radius there is going to be 9. So what that means is this whole length right here in green, that's also the radius, and that whole distance takes a value of 9 as well. Well, we know this value is 3, so then this value here has to be 6. Because if I take 6 plus 3, 6 plus 3 gives you the 9, so the missing value here is going to be 6. Okay, so for this particular problem, there is a typo. It's not looking for OA, it's just looking for this blue distance right here. So this blue distance right there represents the OA. So there was a little bit of a typo with what the question was asking for, so it's just asking for that distance right there. Okay, let's move on to the next question here. Now for the questions on the next section in the homework, a lot of these questions will have to do with using the Pythagorean Theorem. So you need to set up the Pythagorean Theorem in some of these next problems here. Okay, so for the next one here, for question 2C, I'm looking for chord length AB. So AB is right down here. And just like in the previous problem, the numbers are very similar. So this question is exactly set up to the problem that we just had, and I know that this length right here in red, we found that in the previous problem that has a value of a 6. Once we know that, I can definitely find this green length, right? If I know that green length, then I can find the entire length of the chord, because the green length and this blue length are going to be equal. Okay, so let's go ahead and set up a triangle right here. If I go ahead and set the triangle right there on the side here, I know that this has a value of 6, this has a value of 9, and there's my 90-degree box there. So the goal is, let's go ahead and find this value of b right here, and I can do that using the Pythagorean Theorem. So if I set the Pythagorean Theorem here, it's going to be 6 squared plus b squared equals to 9 squared. Okay, so that's the work that I need to do to complete the Pythagorean Theorem here. So let me just kind of erase this triangle here so I have a little bit more room here. So if I take a look at 6 squared, that's going to be 36, plus b squared, that won't change, equals to, well, 9 squared is going to be 81. Okay, and then now I need to solve this problem here, and all I need to do now is I take this 36 and bring it to the other side. So if I do that, that's going to be b squared equals to 81 minus 36. And 81 minus 36 will give you a value of 45. So b squared equals to 45. And then from there, you just take the square root of both sides, and then b would equal to the square root of 45, which is going to be 6.708. Okay, so this is the value of that green region right there. And if I want to find the region of the blue part here, or the whole length here now, I can just take 6.708. I can take this number here and double it. So if I times that by 2, I would get 13.42. So that is the value of chord AB. So a little bit of the Pythagorean theorem there, and then we can just double it up because based on one of the theorems in the lesson, we know that this length and that length are equal. Okay, let's move on to letter D now. Okay, so for letter D, I need to solve for AB. Oops. Okay, so let's solve for AB. Now, where's AB? AB is this distance right here. Okay, so let's go ahead and break this down. If this length here is 8, then that means this length over here has to be 8. And then once we have that, then I can definitely solve for this blue region right here by using the Pythagorean theorem. So if I go ahead and set up the Pythagorean theorem here, There's my 90-degree box. This has a value of 8. 8 on the bottom leg here, and then the hypotenuse is going to be 10, and then I need to find this value right here, b, which is this leg right here. So if I use the Pythagorean Theorem again, it's going to be b squared plus 8 squared equals to 10 squared. All right, so this will be now b squared plus, well, 8 squared is 64, and 10 squared is 100. And then what you do after that is you take the 64, bring it to the other side, and that's going to give you 100 minus 64 equals to b squared, and b squared equals to 36. And then once you take the square root of both sides, then b would equal to 6. So this value of 6 is going to be that value right there of 6. Okay, let's erase all this. Erase all that, erase all that, erase all that. Okay, so I know that value there is 6. Okay, well, one more thing that you have to recognize is that this is the radius, which is 10. That's 10. That's the radius. So that means this right here, although it may not be drawn to scale, that's also the radius, and that takes a value of 10 as well. So if I take these values of 10 and 6, that gives me the value of this length right here, AB. So AB is 16. 10 plus 6 is 16. Okay, let's move on to the next one here, letter E now. Okay, so for letter E, I need a little bit of room here, so I'm just going to erase some of the work from the previous problem. Okay, let's take a look at letter E here. And for letter E, I need to find the value of chord AB, and here's AB right there, so that is what I'm looking for. Okay, now for AB, here's my triangle. And the goal is you should try to find this yellow distance right there. So if you find that yellow distance, then we know that this green distance on the other side has the same value, and then you know that your value of the value of chord AB. Okay, let's go ahead and use the Pythagorean Theorem now. Okay, so this is one of my legs, which is 5. So it's going to be 5 squared plus, and then this right here is my other leg. I don't know what that is, so let's label that B. So this is going to be b squared equals to the hypotenuse, and my hypotenuse is going to be 13, so 13 squared. All right, so you have to do a little bit of work here once again to solve the Pythagorean Theorem problem here, to solve for the missing leg here. So this will be 25 plus b squared equals to, well, 13 squared is going to be 169. And then what you have to do now is you got to take this 25, bring it to the other side here. If I do that, I'll continue down over here. I would have b squared equals to 169 minus 25. And if I subtract 25 from that, I get 144. And then I can take the square root of both sides. And the value of b is going to be 12. Okay, so if I erase all this, I know that this distance right here now is going to be 12. So that means this distance here, the opposite side has to be 12 too. So 12 plus 12 is going to be 24 for the value of E, or the value of AB there. So the answer for letter E is 24. Okay, let's move on to the next one, letter F. For letter F, I need some room again, so I'm going to erase all this. Okay, so for letter F, let's go ahead and just put in some of the given information here, length CD. So CD right here is going to be 2. And then I'm given the value of DE. So DE is this length right here, which is 8. So that means the diameter is going to be 2 plus 8, which is 10. So if the diameter is 10, then I know the radius is going to be half of that, which is going to be 5. So the radius there is going to be 5. Now I need to find the value of AB, and AB is once again the length of this chord. Okay, great. And what I'll do for this particular problem is I will create a center piece right in the middle. So that's my center. And then from my center, I'm going to draw a radius, and I will connect a triangle right there. Now, since I've drawn in the radius, I know the radius has a value of 5. If the diameter is 10, then the radius has to be 5. Okay, now ask yourself, what is this other red distance right here that I'm creating there? Okay, so I know the radius is going to be 5. So if you think about this, this whole red distance right here, this whole thing is 5 as well because that's the radius. But then you have this region right here, which is 2. So this region here has to be 3 because 2 plus 3 gives you 5. Okay, so if I look at my new triangle here, if I highlight this triangle right here in blue, if I just redraw that on the side here, my hypotenuse has a value of 5. And I know that this one leg has a value of 3. And let's go ahead and now find this missing leg right here, which is b. Let's find that b value. Alright, so this is another Pythagorean Theorem problem, and once I find the value of that missing leg, I can double it up, and that will give me the value of the chord AB. Okay, so if I use the Pythagorean Theorem here, this is going to be 3 squared plus b squared equals to 5 squared. That's going to be 9, that's going to be b squared, and that's going to be 25. And once again, like all the other problems, if I take this 9 to the other side, then that will give me b squared equals to 25 minus 9. And 25 minus 9 is going to be 16. And the square root of both sides, that would give me a value of 4. Okay, so let's go back to my original diagram now. Let me just erase all this. Here's my center. And I know this distance right here has the value of 4. So that's 4. That means this distance here also has to be 4. 4 plus 4 gives you a value of 8. So the value of the chord AB is 8. Okay, yeah, we're trucking along here. We got 4 more questions to go, and then we should be done the homework for this first lesson. Okay, for letter G, once again, I need to find the value of chord AB. All right, so let's take a look here. So I know that this length right here and this length right here are equal. So I can label that as x, and I'll label that as x because I don't know the values, but I do know that they're equal. If I set up the Pythagorean Theorem triangle there, it's going to be x squared plus x squared equals to the hypotenuse, and the hypotenuse here is 10. So I'm focusing on this triangle right here in green to set up my Pythagorean Theorem. And this is going to be equal to 10 squared there. Okay, now when you're adding these together, x squared plus x squared is going to be 2x squared. And the value of 10 squared is going to be 100. And then we can divide both sides by 2. Those 2's will cancel. And then you're given a value of x squared equals to 50. And then you can square root both sides. And the square root of 50, let me just calculate that right away. So this value, the square root of 50 is going to be 7.07. Okay, so what we just found there is this length right here in blue is going to be 7.07, and that means this value here also has to be 7.07. So if I just kind of double up my answer there, it's going to be 14.14. That is the length of chord AB. All right, so that one wasn't too bad. Okay, let's move on to letter H. All right, so letter H is one of the more, it's not a super easy one, but I do find that a common mistake for letter H is that students automatically see that as being 15, and they're being told to find the value of AB, so they automatically assume that AB has to be 15 because it appears to be the same distance as the 15 over here. Clearly I can see why students would think like that, but it's actually not the right approach. I know this is right here, it's 15, that's the radius, and this red line right here, this chord, the red chord is not the radius, so we just can't automatically assume that it's 15. Okay, so I know this distance right here in blue is going to be 12. Okay, so let's take a look at this. So I know the radius is going to be 15, but if I know that this length right here is 12, that means this length over here also has to be 12. So right away I can set up the Pythagorean theorem for this red triangle right there, and then I can find this missing side right here in green. Okay, so let's label that as just B. Okay, so if I use my Pythagorean theorem, it's going to be this leg and this leg, so that's going to be b squared plus 12 squared equals to the hypotenuse, which is equal to 15 squared. So that's how I can set my Pythagorean theorem. So this will be b squared plus 144 equals to 15 squared is going to be 225. Okay, and then I take my 144 here and I need to bring that to the other side. And if I do that correctly, then I'll have b squared equals to 225 minus 144. So 225 minus 144 is going to give me a value of 81. And then I can just take the square root of both sides. And then b would equal to the value of 9. Okay, so let's go ahead and update our diagram again. Let me just erase all this. I know this distance here is 12. Okay, and this distance right here, we just found that's going to be 9 right there. Okay, now a key thing that you need to think about now is the radius here in red. That's my radius, right? The radius is 15. Well, this red line right here, that's also the radius, so that has a value of 15. If I know that this distance right here is 9, then this distance here has to be 6, because 6 plus 9 gives you 15, and 15 is the value of the radius. Okay, so as we move on now, this distance right here has to be 6, because this green distance here we found out was 9, and 9 plus 6 has to equal to 15 because they're both the radius. Okay, so now we have another Pythagorean theorem here, this blue triangle right there. Alright, so if I go ahead and set the Pythagorean theorem here, here's the leg and here's the leg. So that's going to be 12 squared plus 6 squared equals to the hypotenuse, which is that missing value right there. I'll call that x. So now we've got to solve this Pythagorean theorem problem here, and then we should be done. So 12 squared is 144, 6 squared is 36, and that's going to equal to x squared. So now we have 144 plus 36 is going to be 180. 180 equals to x squared, and then I can square root both sides. And then once I square root 180, I get 13.42, which is my final answer there. So the value of AB is going to be 13.42. All right, so that's a good thinking question for that particular problem. All right, 2 more questions to go, and then we're done. Okay, let's move on to letter I here. I need to find the value of OA. Okay, so what is OA? Here's O and here's A. So I'm assuming that we're looking for the radius right there. Okay, we're given this value right here is 6. So if that's 6, then we've seen this a few times, then this side has to be 6 as well. And that's because the radius is bisecting a chord, which cuts the chord in half equally. Okay, and then we also are given some information over here and here. We know those two distances are equal, so I'll label that as x, and that part is x as well. Okay, before I kind of get to the Pythagorean theorem setup here, take a look at this blue length right here. Isn't that blue length the radius? It is. So if I take this x and add to that x, x plus x is equal to 2x. So that means the radius, based on how I've labeled my diagram, has the expression 2x. Okay, so if I had to repeat that one more time, this distance right here, I didn't know what it was, so I labeled that as x. And I know that that green distance is also equal to this blue distance, and since this is x, this has to be x. So x plus x, if I add these two guys together, gives me the 2x. Now, since this is the radius, and since this is the radius, I can also label this part right here 2x. That's the key part. Okay, so if that was a bit too fast, just pause and go back and listen to the explanation there. Let me just erase this part now. Okay, so that was x again, that was x. Now take a look at this triangle right here, this green triangle. We have enough information because we know this side is 6, and that means this leg is 6. So if I redraw the triangle down here so everyone can see it a little bit better, if this is 6, that's 6. If this is 2x, that's 2x. And this is x, and this is x, and this is your hypotenuse. That's how you can label your triangle so that you can use the Pythagorean theorem. I can use the Pythagorean theorem now because over here, here's a leg and there's a leg. So that setup is going to be x squared plus 6 squared equals to the hypotenuse, which is 2x. So 2x is being squared. All right, so that's kind of a different kind of a setup there, but it looks doable. And 6 squared is going to be 36 equals to, now 2x squared, that means you're taking 2x and you're multiplying it with 2x. So 2 times 2 is 4, and x times x is x squared. So the answer is 4x squared. So my hypotenuse works out to be as 4x squared. Okay, and now we have to do a little bit of algebra here to solve this green expression here. Maybe the best way to do this is take this x squared and move it to the other side. If I do that, I get 36 equals to 4x squared minus x squared. And then I have the 4, and there's an invisible 1 here. So 4 minus 1 is going to be 3. So 3x squared equals to 36. And then I can divide both sides by 3. If I do that, those 3 cancels, and 36 divided by 3 is 12. So 12 equals to x squared. And then I can take the square root of both sides. All right, so the square root of 12 is going to be 3.46. Now remember, this is the value of x. So x is 3.46. Okay, let's go back to my diagram here because I kind of lost track of how I've labeled things. Okay, there's my radius, which is what I'm trying to find. Now remember, this was x, and this was x, and this is 2x. So if x equals to 3.46, then the radius is double that. So 3.46 times 2 is going to give me a value of 6.93. So that's the value of OA, 6.93. So remember, the value of x here, that was the value, that had a value of 3.46, and the radius is double that. So I need times 3.46 by 2 to get 6.93. All right, we're almost done here. Let's go over this very last question here, letter J. I need to find the value of OA. So OA is this distance right here. So let me just break this down as quickly as I can here. I know my diameter here is going to be 20. If my diameter is 20, then my radius has to be 10. So the way that's useful for this particular problem is I can draw a radius like that. That green line right there is my radius, and that radius has a value of 10. Now, another kind of property that's been going around for this particular homework is that if you're given this chord, which is this yellow value right here, that's called a chord, it has a value of 16. And since it's perpendicular right here, that means these two sides both will have equal value. So if the whole length is 16, then we can divide that by 2, and I know that this red distance here is 8, and this blue distance here is going to be 8. But right away, we kind of have our new triangle right here. If I just draw that right here, this has a value of 8, that has a value of 10, and I just need to find this b value, which is what we're looking to find. So that's our Pythagorean Theorem set up for the triangle, and if I set that up correctly, which is going to be 8 squared, which is the leg, plus b squared, which is the other leg, equals to the hypotenuse squared, then there's my setup for the Pythagorean Theorem, and we just need to solve this. So this will be 64 plus b squared equals to 100. Then you take this 64, move it to the other side. So now I have b squared equals to 100 minus 64. That's going to be 36. And then I can square root both sides, and that gives me a value of 6 there. Okay, so there's my answer there that has a value of 6. All right, so that completes this homework video guide.